All right, everyone. Sorry for the late post, but let's go ahead and get going on this. All right, so this is going to be homework 5.3, part 2, page 364, numbers, what was it, 14 through 16? And then 21 through 29. And that's odd. All right, let me double check. Not that I don't trust myself, but let's see. 14 through 16, 21 through 29 odd. That is correct. Okay, so let's start with 14. 14, we've got cosine x times cosine x minus 1 equals 0. All right, so this one is actually set up for us already. So this is cosine x parentheses cosine x minus 1 equals 0. All right, this is actually already factored. So we don't need to do anything special here because this is already two things being multiplied together. So all we have to do is write it down as cosine x equals 0 or cosine x minus 1 equals 0. Right? Solve each of them. The one on the right, cosine of x equals 0. Look on your unit circle. You're going to get x equals, let's see, as cosine 0, that's going to be pi over 2. And also at 3 pi over 2. All right? You can also write it down as the general solution, right? Remember, these are just a solution. Okay, the general solution is going to be x equals pi over 2 plus pi k, because pi over 2 and 3 pi over 2, these are exactly half of a circle apart, right? So you can do that. Cosine x minus 1, solve that out. You're going to get cosine x equals 1, and that's going to happen at x equals 0, okay? And solution for that, here, it's just x equals 0. General solution for that, x equals 0 plus 2 pi k. All right, so that's what that is. Actually, let me pull up a unit circle just in case. Let me pull up. Give me a second. Just in case I need to explain something to you guys, I need to show something. Give me a second. Okay, so just to get a picture of it, I like that one. Hello, there it is. I need to copy image. All right, sorry about that. And I am going to go ahead and next page, I'm going to go ahead and glue, paste that in. Okay, so just in case I need it. Okay, so that was 14. 15. 15 is sine squared x equals 3 cosine x. Oh, cosine square x. This one looks interesting. I think I'm going to go ahead and subtract the sine squared x over. Yeah, why not? Right, so it's going to be 0 equals 3 cosine square x minus sine square x. Okay, I'm going to go ahead and use a trig identity. The sine square x plus cosine square x equals 1. Okay, so if I want to substitute for sine square x, actually, let's do this. See how that's already a minus sine square x? I'm going to move the sine square x to that side. So this will be negative sine square x. And I'm going to go ahead and move the 1 to the right-hand side, or left-hand side. So on the left-hand side, I'll have a cosine square x, right, minus 1. Yep. And that will equal sine square, a negative sine square x. Right, so this one's going to be, right, so instead of doing negative sine square x, I can do cosine square x minus 1. Right, so I'm going to go ahead and rewrite that as 0 equals 3 cosine square x. Right, and this one, if you want, you can write it as a plus minus sine square x. Okay, because that's what we have. Right, so I'm going to go ahead and add a cosine, because that negative sine square x is actually a cosine square x minus 1. So putting it all together, I will get a 4 cosine square x minus 1. Hey, that's pretty cool, because now I can actually factor this. This is a difference of squares, 2 squares, right? To get 4 cosine square x, I will need to have a 2 cosine x and a 2 cosine x. And to get a negative 1, I would need a positive 1 and a negative 1. This one's pretty cool, actually. Works out pretty nice. Okay, you can always double check this by doing distributive property. I'm not going to do it, but you can do this. I check it by doing distributive property. So does that make what we have up there? Right? So, oh, sorry, this one. Right? So check to see if that is equal to 4 cosine square x minus 1. Right? So you can do that on your own time, but that I am going to say is going to be true. Right? So that means we're going to write it as 0 equals 2 cosine x plus 1, and 0 equals, and you can put the 0 on the other side. I just wrote it like this because this is just the way that it's set up. Minus 1 on this one. You're going to solve it. So this one's going to end up being minus 1 equals 2 cosine x, and divided by 2, so you get negative 1/2 equals cosine x. And again, let's look at the unit circle. When is the cosine equal to negative 1/2, right? So that's what we're looking for. So cosine is equal to negative 1/2 where? Cosine, remember, is the x value, so right here, right here. Right, so our two answers are going to be 2 pi over 3 and 4 pi over 3. So x equals 2 pi over 3, and x equals 4 pi over 3. Okay, that's just a solution, right? Our general solution, right? And notice that these two are on the left-hand side, and they're not across from each other, or they're not 90 degrees from each other, right? So we cannot use any of the fancy stuff. So we would just have to use a 2 pi k, or if you're using degrees, 360k. So the general solution would be x equals 2 pi over 3 plus 2 pi k. And the other answer is x equals 4 pi over 3 plus 2 pi k. Okay. For this other one, solve it just normally, and you get 1 equals 2 cosine x divided by 2, and you get 1/2 equals cosine x. Right, and so we would get x equals for our solution. Right, and again, this one we're looking for, when is the x equal to 1/2? right? So x is equal to a half right here and right here. So when is the cosine equal to a half? At those two locations. So that's a half right there, and that's a half right here. So our two answers are pi over 3 and 5 pi over 3. Okay. And they're both on the right-hand side. So they're not across from each other. So we're going to go ahead and say x equals pi over 3 and x equals 5 pi over 3. Okay, and that's our solution. Our general solution is going to be x equals pi over 3 plus 2 pi k, and x equals 5 pi over 3 plus 2 pi k. Remember, I'm just doing this as extra. You don't need to do both, right? And more importantly, we're just looking for the two solutions for that, and then the two solutions for this one, right? So don't feel like you need to do it all the time. I'm doing it as kind of like a lesson that I will always be doing it. Okay, you don't have to do it. I will always do it, but you just pay attention. 16. So this is 3 tangent square x minus 1. Ooh, I like this one. This one's already factor. This one's going to be tangent square x minus 3 equals 0. Okay. So because they're both, it's already factored. See the two parentheses? We can just say that each of them are equal to 0. So 3 tangent square x minus 1 equals 0. And tangent square x minus 3 equals 0. All right, we're going to go ahead and solve each one. So minus 1, 3 tangent square x equals positive 1 divided by 3. Get tangent square x equals 1/3. All right, you're going to go ahead and take the square root of both sides to get rid of the square, which means you got plus or minus. So you finally get tangent x equals positive, negative. Square root of 1 is just 1, so I'm not going to write square root. Square root of 3 is radical 3. Okay. So for tangent, I'm actually looking for 1 over the radical 3. Radical 3 on the bottom and positive or negative. Okay, it doesn't matter. So just looking at my unit circle. And so if I need to have radical 3 at the bottom, and I know tangent is sine divided by cosine, and the sine is the y divided by the x. So I need the radical 3 at the bottom. So I will need to have, let's see, I need to have this on top and this on the bottom, right? So sine is 1/2 divided by cosine is radical 3 over 2. And just like how we've done before, the bottoms cancel, the bottom of the top and the bottom of the bottom cancels, and you will be left with 1 over radical 3. And that is actually what we are, looking for. Right, so we're looking for 1 over radical 3 right here. Okay, positive or negative. So that means that I have my answer. My first answer is right here, pi over 6. Okay, and that comes out to be positive. This one's positive. Okay, my next answer is going to be right here, because that one's going to be 1/2 divided by negative radical 3 over 2. Again, then these cancel, and you will end up with negative 1 over radical 3, and that's a negative. Okay, and just in the interest of time, our other answer is going to be right here, 7 pi over 6, and our last answer is going to be right here, 11 pi over 6. So we will have all 4 of these. Okay, and just kind of just setting it up as a mental note, these are exactly across from each other. So we can, when we do our general solution, all we need to involve is just the pi over 6. And then these are across from each other as well. And when we do our general solution, all we need to do is involve the 5 pi over 6. Okay? So pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Our 4 answers. So x equals pi over 6. X equals 5 pi over 6. X equals 7 pi over 6. And x equals 11 pi over 6. That's our solution. Okay, that's in just the first round of the unit circle. Okay, if we want a general solution, it would be x equals pi over 6 plus half a circle, because remember when I was showing you, it's half a circle away. So pi over 6, right? Again, pi over 6 is across from 7 pi over 6. So I don't need to involve 7 pi over 6 anymore, because when I add half of a circle, which is pi, I will already have the 7 pi over 6. And the 5 pi over 6 is the other one that I need. Okay. So pi over 6 plus pi k, and the other one is x equals, what is it? 5 pi over 6. Excuse me. 5 pi over 6. Five pi over 6 plus pi k. Oops. I don't know what I'm doing. Pi k. Right? Now tangent squared x minus 3. You're going to go ahead and add 3. So you will get tangent square x equals 3. Square root both sides. You square root, you got plus or minus. Right? And you will end up with tangent x equals positive or negative radical 3. And notice that that is exactly the opposite or the reciprocal of our other one. Right? So I kind of know where this is going to head. So for that one, instead of using these, we will actually need these right here, right? Because again, if we work the math out, see here, I'll erase everything. If we work the math out, if we go the sine, because we're still talking about tangent, so radical 3 over 2 divided by the cosine, which is 1/2, 1 over 2. And again, same thing happens. The 2's cancel, except this time when our answer comes about, we get radical 3 over 1, and then we don't have to write the 1. So now we get radical 3, and those are the positives. Right? So just by knowing that much, we know that our answer is going to be pi over 3, 2 pi over 3, and you can go ahead and try it out yourself doing the division for these two. 4 pi over 3, again, you can try that out by doing the division for these two. And we know our last answer is going to be 5 pi over 3. Again, you can try that out. Here, we'll actually try it out. Negative radical 3 over 2 over 1/2. Right? Again, the bottom 2's cancel, and you will end up with negative radical 3 over 1, which you could just write as negative radical 3, and that's a negative 1. So that's our 4 answer: pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay. And again, when we're writing our general solution, we can just write pi over 3 plus half a circle, because this is exactly halfway across, and 2 pi over 3 plus half of a circle, because this is exactly half of the circle across, pi across. Okay. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So your answer, x equals pi over 3, x equals 2 pi over 3, x equals 4 pi over 3, and x equals 5 pi over, oops, ran out of space. Let's move it over. There we go. X equals 5 pi over 3. Okay, and that is our solution. General solution would be x equals pi over 3 plus pi k, and x equals 2 pi over 3 plus pi k, right? So these first two, so this one plus half of a circle gets you that one. So we took care of that already. And then this one, 2 pi over 3 plus half a circle takes care of that one, right? So just these two equations down here will take care of all four of those um, answers up there, plus many, many, many more. Okay. Right. That was 16. And then we also have 21 through 29 odd, right? So I'm going to use the next page. So 21. I guess I'll use blue. Nah, actually, I like to say the colors for special occasions. So right now it's not too special. 21 is 3 tangent x, tangent square x equals tangent. Right. Let's go ahead and put equals tangent x. Let's go ahead and put a tangent on the left-hand side. So we will have 3 tangent square x minus tangent x equals 0. Okay, from here, I'm going to go ahead and factor the tangent out of both of these because both of these terms, this first term and this second term, they both contain tangent x's. So we're going to go ahead and factor a tangent x out of both those terms. So tangent x factors out, left over 3 tangent x. If you factor the tangent out of the minus tangent x, you get minus 1. That's going to equal 0. Okay, you already have factors now. Okay, that's your first factor, and that second parenthesis is your second factor. So we get, so tangent x equals 0, and 3 tangent x minus 1 equals 0. Okay, I'm going to go ahead and solve the second one. Right, so we go ahead and minus 1, so 3 tangent x equals 1. Go ahead and divide by 3, so it'll be tangent x equals 1/3. Right. So when is the tangent going to equal 0? Remember, tangent is sine divided by cosine, or the y divided by the x. So only place where that happens is the y 0 divided by the x 1. That makes 0. Okay, and also 0 divided by the x negative 1, which is 0 also. So your two answers are 0 and pi. And again, they're across from each other, so you can use a general solution, a special general solution. Right. So that one we have answers x equals 0 and x equals pi radians. Okay. So those are the solutions, or you can say x equals 0 plus pi k. Right. For the second one, when is the tangent going to equal 1/3? Right. So again, look at your unit circle, and you're going to go the y divided by the x, and you want that to be 1/3. Right. So just looking at all of this, I don't think that's going to happen. Right. Because we already done the work. We already done all the tangents. This divided by that gives you 1 over radical 3. Okay, so that means that all of these are the same, except some are negative, some are positive. Okay, these are all the same, so that's all. All of these are going to give you some kind of a 1 over radical 3. Okay, so we don't need that. And all of these, radical 3 over 2 divided by 1/2. Okay, all of those are going to give you radical 3 or negative radical 3. So these two, and these two, they're all going to give you some kind of a radical 3. Okay, so that's not going to give you 1/3. Right, and in the middle, radical 2 over 2 divided by radical 2 over 2. Okay, and all the middles, that's going to be negative, but they're all going to give you the same thing, and they're all going to give you something that has to deal with the 1. Right, so this will give you 1, this one will give you 1, this one will give you -1, and this one will give you -1, but they're not going to give you, what was it, 1/3. Right, so we actually don't have any solution for that. Okay, so this one is no solution. All right, so our only answer is going to be x equals 0 or x equals pi, or you can write a general solution, which is right there. Okay. All right, so that was 21. I was thinking about checking my answer in the back, but I think we're fine. All right. Okay. 21. I'm trying to speed this up. So 23. Secant squared x minus secant x. Okay. Well, actually, this one has no solution from your unit circle. Okay. There is a way to figure out a solution from the calculator, but no, we'll talk about that some other time. Right. But for now, we'll just say no solution. So I'm interested to see what the back of the book says, but I want to get through these first. Equals 2. All right. So just kind of working on this. Let's see. Let's go ahead and move the 2 over to the left-hand side. So we will have secant square x minus secant x minus 2 equals 0. Okay, this looks just like the factor of x squared minus x minus 2, right? What does that factor into? Okay, so if we work this out, we will get x and x. To get -2, you need a -2 and a +1, or a +2 and a -1. But seeing that we need it to have a -1, we will need to have it as -2 and +1, like we have it, like how I have it. So I know my factor is going to be secant x minus 2 and secant x plus 1 equals 0. Okay, so the two equations, secant x minus 2 equals 0, and secant x plus 1 equals 0. Minus 2, or add 2 to both sides, so you get secant x equals +2. Okay, so when does that happen, right? So x equals what? Right. Remember, secant is related to the cosine. It's just to flip the cosine. So when we flip the cosine, we want to have a +2. Right? And if we look at this, when we flip the cosine, so here's all the cosines, right? And we're only looking for the 1/2. So this one, if we flip it, we'll get +2. So we know that's our answer. And this one, if we flip it, we'll get +2. So that's our answer. Okay. This one, if we flip it, we will get -2. And this one, we flip it, we'll get -2. So we don't need those two. Right? So our only two answers are pi over 3 and 5 pi over 3. So x equals pi over 3 and x equals 5 pi over 3. Okay, and those answers, you see they're both on the right hand side, so you can't use a half circle for this because half circle is right here and half circle here is up here, so we can't do that half circle thing. So we have to use a total 2 pi. Okay, so that's our solution. If we wanted our general solution, here's the solution. Our general solution will be x equals pi over 3 plus 2 pi k. And the second one will be x equals 5 pi over 3 plus 2 pi k. Okay, secant x plus 1, we're going to subtract 1. So we want secant x equals -1. And remember, secant is a reciprocal of the cosine. So if we flip the cosine over, we want to get -1, right? So let's go back here and look for all the cosine. Remember, cosines are the x value. So look for all the cosines. If we flip it, we'll get -1. Okay. Only one that works is this -1 here, right? Because -1 is the same as -1 over 1. And if we flip it, we will get 1 over -1, which is still -1, right? So that's the only one. Right, so this is the only one, and it's pi. Right, so that one, secant x, when is it equals -1? That's when x equals pi. Okay, so that's our solution. Our general solution is just going to be x equals pi plus 3. Sorry, plus 3. I don't know what I'm doing. Plus 2 pi k. Okay, so those are our solutions. This one, we have a total of 1, 2, 3 solutions in that first unit circle. Okay, first revolution of the unit circle. 23. Right, next one. 25. 2 sine x plus cosecant equals 0. This one's interesting. Actually, I don't know. These are squares, so you really can't do much with the Pythagorean identity. Maybe you could do it like this: 2 sine x plus 1 over sine of x. Okay, I think I have an idea. Equals 0. Okay, so this is not guys. I really don't know how to do this. This is fresh. The other ones are pretty, straight by the book, but this one's a little bit fresh, right? Let me go ahead and put a 1 underneath here and get a common denominator of sine of x. So that means that this one's already sine of x. That's good to go. This one I need to times it by sine of x, which means I need to times it by sine of x. Okay, and that's going to give me 2 sine square x over sine of x plus 1 over sine of x equals 0. Okay, and by doing this, I can now combine it into one big ugly fraction. So the top will be 2 sine square x plus 1 over sine x. All right. 1 minus cosine. I'm thinking this might be, I don't know, double angle formula. Maybe I could write it like this: 1 over sine of x times 2 sine squared x plus 1. And this is over 1, so, but I don't need to write that, right? Because if you multiply that out, you get back to here, right? So I'm just showing you that you can do that. Plus 1 equals 0, and we have written a factor. So we can write it as 1 over sine of x equals 0, and 2 sine squared x plus 1 equals 0. This one was actually pretty nifty. It's a low blow. I mean, you had to really think about it, and I mean, you can see I was a little stumped for a little bit here and there. And this is actually equal to cosecant. So we're looking for when is the cosecant equal to 0, right? And remember, cosecant is just the sine flip. I mean, we even have it right here, right? So when is the cosecant equals 0? So we're going to look at all the signs, and if we flip it, we should get 0. So looking for when we flip the sign, we'll get 0. Right? Let's see. 0 right here, that's a sign. So basically you can say 0 over 1, right? But if you flip it, it's going to be 1 over 0. And that's actually undefined. So that's not going to be what we want. So it's not going to be either this one or this one, right? So so the answer is not 0 or pi. Where else? Looking at, and you flip all of these, right? Doesn't matter which one you flip, but you will never get a 0. Right? All of these will not give you zeros. Right? This one, if you flip it, you get 2. So that's not a 0. 1, if you flip 1, you will get, you flip it, you get 1 over 1 still, which is 1. Same thing at the bottom, right? If you flip -1, you get -1. So there is no answer for that. Okay. So this first part, right? So when is a cosecant equal 0? Oh, this has no solution. Okay. Oh, the last one, when it had no solution, I would have. Did I write anything for that last one? No. Oh, it's probably this one. Oh, yeah, I did write no solution right there. Yep. Or no solution from the unit circle. Okay. This one here. This next one. Subtract 1. So 2 sine square x equals -1 divided by 2. Sine square x equals -1/2. Square root both sides. Right. And you get sine x equals, let me double check, see if that should be a plus. Yep, that should be a plus. So square root of -1/2, well, you can't do that, right? That's actually going to be plus or minus 1 over radical 2, and then that's I for imaginary, right? And that's not going to go because these should be real numbers. So that one should have no real solutions as well. Okay, so this one actually should have no solution, right? So this one's what, 25? I'm actually going to check the back of the book, right, if you don't mind. Give me a second. This is chapter 6, or chapter 5. All right. 5.3. If anything, I will get back to you guys on it. Chapter 5. Where am I at? 4.8. I need 5.3. Well, that's chapter 5. 5.2 and 5.3, number 25. 25, back of the book says, back of the book is missing. What the heck? 10, 12, 14, 16, 18. Why are these even? Maybe, oh, you know what? These are instructors' answers. Maybe they have student answers. Okay, I think I have a different book than you guys. Anywho, we can. Yeah, that is weird. Oh, there it is. Answer to odd. My bad on that, everyone. Chapter 5. So you probably are, if you check, you probably win already because I am like slow at this. Let's see. Going. Chapter 6. Okay, we're in chapter. Okay, I'm in chapter 5. Okay, 5.3. There it is. Number 25. Okay, 25 says no solution. If you look at, oh my gosh, it took me all this time. All right, and then while I'm at it, I'm going to check the other no solution. 21. Looks like we only got these 3 answers. So I'm just checking 21. You got 0, Wow, 21 has a bunch of answers. 0, we got pi, 0 and pi. And then it also has, so I'll have to double check this for you guys. But 21, the answer also has pi x equals pi over 6. Okay, I'll have to double check that. 5 pi over 6, pi, 7 pi over 6, and 11 pi over 6. Okay. Now, I'm not sure if that's for this answer here or if that's for this over here. Okay, but I'm going to double check that for you guys. Okay, 1/3. So, yeah. Okay. I might do that in class and not on this video because I think it's going long enough already. So 25, right? 27 and 29. So two more. 27. Yeah, I'll actually get a placeholder. Okay, 27 is cosine x plus sine x tangent x, sheesh, equals 2. All right, I'm not liking that equals 2. But sine x tangent x, I'm thinking we could do the same thing. So we could write this as cosine x plus sine x. We could put it as sine x over 1 times tangent is sine over cosine. And then equals 2. Right? So this is going to be cosine x plus sine square x over cosine x equals 2. Then go ahead and get a common denominator of cosine x. So we're going to times this by cosine x and this by cosine x. This one might work out pretty nicely. Let's see. So we will have cosine square x over cosine x plus sine square x over cosine x equals 2. All right, combine that. We will have a cosine square x plus sine square x over cosine x equals 2. Right, and then if we use the trig identity for this part right here, that's 1. So we would get 1 over cosine x equals 2. And this one just comes out to be secant x equals 2. Right? So when is the secant equal to 2? And remember, secant is the cosine, and even says right here, flipped. Right? So if we look at the cosine and we flip it, where will we get 2? Right? Well, you get 2 right here. That's a cosine. You flip it, you get 2. Right here also, that's a cosine. You flip it, you get 2. This one, if you flip it, you get -2, so that one doesn't count. And this one, if you flip it, you get -2, so that one doesn't count either. Okay? These are the signs, so we can't use that because we need the cosine flipped. So the only two answers are pi over 3 and 5 pi over 3. And if I'm doing general solution, these are not across from each other, so I cannot use a plus pi k. I have to use a plus 2 pi k. So, answer is pi over 3 and 5 pi over 3. So for that one, answer is x equals pi over 3 and x equals 5 pi over 3. Okay, those are your solution. General solution is going to be x equals pi over 3 plus 2 pi k. You need the whole thing. And then x equals 5 pi over 3 plus 2 pi k. The whole thing also. Okay, and that was 27. 29, last one. I hope this is not 1 hour yet, but it may very well be because I did a lot of talking and wasted some time. So secant. And again, I apologize, but hey, lucky for you, you don't have to sit through this. You can fast forward whenever there's a little downtime. So 29, secant square x plus tangent x equals 3. I think we should turn the secant into a one of our Pythagorean trig identity. What do you guys think? Right? I think we should do that. So secant square x, we're going to use this Pythagorean identity of, let's see, secant square x, I'm going to use the 1 plus tangent square x equals secant square x. And we actually have that. We have secant square x, and we can rewrite it as tangent, or excuse me, 1 plus tangent square x. All right? So instead of writing secant square x, we're going to write down 1 plus tangent square x. So 1 plus tangent square x plus tangent x. And then I'm going to move this 3 over, so it would be minus 3 equals 0. So I have a feeling this one's going to be a factor with a diamond or with the x factory. And you can combine the 1 and the negative 3. So you will have tangent square x plus tangent x. 1 and negative 3 makes negative 2 equals 0. Okay, and from here, this is likened to you writing this as x squared plus x minus 2 equals 0. Okay, but we don't have to worry about the 0 just yet. Okay, factor for that. Okay, this is similar to what we did earlier when we did the factoring. X times x is x squared. To make negative 2, it's a positive 2 and a negative 1, or a negative 2 and a positive 1. But seeing that this middle piece is a positive x, we will need a positive 2. We need a 2 to win out. So it'll be plus 2 and minus 1. And you can double check that by doing distributive property. Okay, you can double check that if you want. Right, so my factors for my trig equation is going to be tangent x plus 2, tangent x minus 1. Oops, I don't know what happened, equals 0. Okay, so you're going to write down the two equations. Tangent x plus 2 equals 0, and tangent x minus 1 equals 0. Okay, solve this one. We get tangent x equals 2. Right, so what does x equal? Okay, remember, tangent is sine divided by cosine. So when I take all the sines and divide by all the cosine, I want 2. Right, and actually, that's not going to happen. Right? If you take a sine and divide it by, so negative 1/2, and divide it by cosine, okay, that will never give you a 2. Right? Because when we do this, the 2's cancel, and you will get negative 1 over radical 3. Okay? And if you do these other ones, so these don't work. Okay, these don't work. These inside ones don't work. Oops. Okay. And if you do the outside ones, right? I'll use blue. If you do tangent, which is this negative radical 3 over 2, and it's the same for any one that you use, divide by 1/2. Okay, you will get exactly the opposite. These cancel, and you will get radical 3. In this case, you get negative. So these outside ones don't work. So this one don't work, this one don't work, and this one don't work. And if you do the middle, tangent is the middle one's sine divided by cosine, radical 2 over 2 over radical 2 over 2. You will always get 1 or negative 1, which will not work either. So this one will give you 1, nope. This one will give you negative 1, nope. This one will give you 1, nope. This one will give you negative 1, nope. Right? So that doesn't work. And then you try all the four corners, right? The 0, 90, 180, 270. You go sine 0 divided by 1. Check it on the calculator. You get 1. Oops, sorry, you get 1. I lied. You get 0. Right, that doesn't work. Okay, so that means that this one also doesn't work, because 0 divided by negative 1 is still going to be 0. So that doesn't work, and I need 1. Right? Sorry, not 1. I need to have 2, not 1. I need to have 2. Right? And the top, if I go 1 divided by 0, top and bottom, right? 1 or negative 1, doesn't matter, but 1 divided by 0 is actually undefined. And negative 1 divided by 0 is still undefined. So there is no answers for that. That does not give you or allow you to have an answer for this one. Okay, at least not from your unit circle. And pretty confident there is no answer, period. So you can check the back if you like. So this one, so this x, for this side of it, x is no solution. Okay. Now tangent x minus 1, if you add 1, tangent x equals 1. Now there it has answers. Okay, and I already talked about it. Right? The answers are going to be, okay, so we're near the end, guys. If you divide this, the sine radical 2 over 2 over radical 2 over 2, you will get 1. Yay, I want that. And this one down here also, sine negative radical 2 over 2 divided by cosine negative radical 2 over 2, you will also get positive 1. Okay, and that's what I want. So I want the pi over 4 and the 5 pi over 4. And they're across from each other, so I can do the general solution with just the half circle. So pi over 4 and 5 pi over 4. So x equals pi over 4 and x equals 5 pi over 4. Okay, those are my solution. My general solution is just x equals pi over 4, that first one, plus half a circle. So it's just plus pi k, and then you have that. So ideally, you only have 2 solutions. Okay, or a general solution, you have 1 general solution. Okay, that was 29, and I apologize that took a while, but thank you for hanging in.